Welcome to my channel. Today we'll be discussing what number system is all about. A number system is a method of representing numbers using digits or symbols in a consistent manner. Now, there are some types of number system that you need to be aware of. One of them is binary. So when you hear by, what comes into your mind? By means two. So binary system or number system is a base 2 system. Base 2. That means it has two numbers which are 0 and 1. These numbers are used in computers to operate computers. So another one you need to be aware of is decimal number system. So when you hear decimal, you are talking about base 10 number system. Okay, in this base 10 number system, there are basically 10 digit numbers which start from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 which were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So decimal number system has 10 numbers, which these numbers are used in our everyday life for counting. Okay, so another type of number system you need to be aware of is the octal number system. Octal. When you hear octal, what also comes into your mind? Think about octagon, which is base 8 number system. It's a base 8 number system. That means it contains 8 numbers, which are 1, 0, 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. Okay, so these numbers are 8 digits. That's why it's called base 8. Now, another one you need to be aware of is hexadecimal number system. The word hexa, when you hear hexa means 6, and then decimal means 10. So when we say hexadecimal, we're talking about base 16 number system. Base 16 number system contains 16 digit numbers which start from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So, and then the alphabet here: A, B, C, D, E, and F. So count it. We have 0 here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's a base 16 number system. So this A represents 10, 11, 12, 13, 14, and 15. All right, let's solve some examples. Let's say we want to convert 45 decimal to binary. When you see subscript attached to a number like this 10, it means that that number is in base 10 number system. So how do we convert this to binary? So since we are converting it to binary, we are going to use 2 to divide 45 till we get to 0. Now look at how I'm going to do it. Look how I'm going to do it. I will use 45. 45 divide by 2. This will give us 45 divided by 2 will give us 22 is equal to 22. 22 remainder 1. Yes, 22 remainder 1. So now I'm going to use this 22 to still divide it by 2. I'm not going to use the remainder, okay? Leave the remainder aside. So I'll now say 22 divided by 2, which will give me equal to 11 remainder 0, okay? So I'll still use 11 again, divided by 2, and I'll now say 11 divided by 2, then I'll get 5 remainder 1, okay? So I'll still use 5 to divide it by 2, so I'll see 5 divided by 2. This will give me 2 remainder 1, okay? So I will now use 2 divide by 2. I'll have 1 remainder 0. So I'll now use this one here, 1 divide by 2. So I'll have 0 remainder 1. Like I said, as soon as you get to 0 here, then you can stop, okay? So now, how do you read the numbers now? You read it from bottom to up. That means from the bottom here to top. So reading it from bottom here to top, so we now have 45 is equal to, from top here we have 1 0 1 1 0 1 in base 2, okay? So the value of 45 binary in binary is 110101, okay? Let's take another example. 45 in base 10, convert it to octal, that is base 8. So that means that initially we used to divide, so now we are going to base 8. We are going to use 8 to divide 45 till we get to 0. So we start from 45 divide by 8. This will give us 5 remainder 5. So now use 5 again. We use 5 divide by 8 again. So we'll get 0 remainder 5. Now we have gotten to 0. We can now stop there. So we now have 45 base 10 is equivalent to 55 in base 8. So the value of 45 in base 10 is equivalent to 55 in base 8. So now you have learned what binary is all about and the types of binary. Feel free to subscribe and share.